So we're going to look at more advanced word problems, which are going to be all about distance, rate, and time. So everything is going to be based off of this equation. Distance is equal to rate times time. Okay, D is distance. Oops, writing with the wrong pen. R is rate. Distance will usually be in miles or kilometers. Rate, miles per hour or kilometers per hour. T is time, which would be in hours. Okay, so really simple equation, your distance, get distance of anything, you're multiplying your rate, your speed, times your time. Okay, so let's just get into the problem so we can get an idea of how this works. All right, an airplane takes 8 hours to travel a distance of 7,168 kilometers against the wind. The return trip takes 7 hours with the wind. What is the rate of the plane in still air, and what is the rate of the wind? Okay, so here's going to be the setup for any and all of these distance, rate, time problems. So we're going to want to make a chart. R, our rate, T, our time, and D, our distance. Okay? And we have the plane going against the wind. So it's fighting the wind and then going with the wind. Okay, so I'm going to make 2 rows against wind with wind. Okay? All right, so this is your setup, the chart you're going to make for all of these. The airplane takes 8 hours to travel a distance of 7,168 kilometers against the wind. So for against the wind, I can fill in 8 for the time and 7,168 for the distance. Okay. And then with the wind, we're going 7 hours, and the return trip for the distance has to be the same as the original trip. Okay, if they're going 7,168 kilometers to get there, they're going the same distance to come back. Okay, so let's fill that in for distance. Now, for the rate, you're not told anything about the speed, how fast the airplane is going. In fact, that's what we want to find, how fast the plane is going in still air, okay, and what the rate of the wind is. So, if you think about what's happening when you're going against the wind, when you're going against the wind, you're fighting the wind. So normally you go a certain speed. Let's say your speed is 500 kilometers per hour. Okay. Maybe the speed slows you down by 50 kilometers per hour. So that your speed is going to be 500 minus 50 or 450. Okay. With the wind, opposite, the wind is going to speed you up. All right. So if the wind speed is 50 and your normal speed is 500, then your actual speed is going to be 550 because you're going to be going faster. So what we're going to write for with the wind and against the wind, let's say our normal speed is x, right? We said for against the wind, it slows you down by a certain amount. And I just made up a hypothetical amount. So we're going to say the amount that it slows you up or speeds you down by, we're going to call that y. So for against the wind, we're fighting the wind, you're going to slow down. So we're going to say that's going to be x minus y. For with the wind, we're going to say it's x plus y. Okay, and what do x and y stand for? X is going to be speed in still air, meaning just the normal speed of the wind. Okay, and I mean just the normal speed of the plane. And y is going to be the rate of the wind. Okay? So then if we use the fact that distance is equal to rate times time, we can make our system of equations. So for against the wind, distance is equal to rate times time. So distance is 7,168. Rate is x minus y. And time is 8. For with the wind, 7,168 equals x plus y times 7. Okay, so what we're going to do is we're going to distribute, of course, and I'm going to switch the order. I'm going to write it like this, which is going to look better. 8x minus 8y equals 7,168. 7x plus 7y equals 7,168. All right, so we're going to solve this by elimination, and we're going to need least common multiple, which for 8 and 7 is 56. So I'm going to make a 56 on top by multiplying everything by 7. And I'm going to make a negative 56 on the bottom by multiplying everything through by a negative 8. Okay. All right, so we have, after doing that, 56x minus 56y equals, let's see, calculator, 7 times 7,168 is 50,176. Okay, on the bottom we have negative 56x minus 56y equals negative of that number. Eight times 7,168 equals 57. Oops. 344. Okay, so this will cancel out. We got negative 112y equals 5176. Negative 7,168. Divided by 112 is 64. So y is 64. Okay. And then to get x, let's substitute in. I'm going to have to borrow some space for number 2. So I'm going to take the top equation here. Oops. I'm going to stick in that equation. Okay, so we're going to get 8x minus 8 times 64 equals 7,168. Okay, so 8x minus, what's that come out to? 8 times 64 is 512. Okay, we get 8x equals plus 7,168. 7680. Okay, so that means x is 960. Okay, so what this means is, if we look back at what we wrote over here, x is the speed in still air. So still air is 960, and that's in kilometers per hour. Okay, and rate of wind, that is y, and we got y is 64 kilometers per hour. So yeah, these are kind of long problems. Okay, so let's clean up the space in number 2 so we can start going over that one. Okay. Still got more. All right. So again, we're going to make our RTD charts. Okay, let's see what's going on here. Motorboat takes 5 hours to travel 200 kilometers going upstream. The return trip takes 4 hours going downstream. What is the rate of the boat in still water, and what is the rate of the current? Okay, so we have upstream and downstream. Let's see what we can fill in. So for upstream, 5 hours, 200 kilometers. Return trip, obviously also has to be 200 kilometers. And 4 hours. Okay, so this is gonna sort of be like number 1. If you're going upstream, okay, you're kind of fighting gravity, all right? You're fighting the current in the water because the current wants to push you down, but you're going up. So what we're gonna say when you're going upstream, you're slowing down by a certain speed. So we're gonna say X is rate in still water. Y is going to be rate of the current. Okay, so upstream you're slowing down. That's going to be X minus Y. Downstream you're speeding up. The current will make your boat go faster. So that's going to be X plus Y. All right. So if we set up our distance equals rate times time, we're going to get 200 equals 5 times X minus Y. And we're going to also get 200 equals 4 times X plus Y. So let's change our order and simplify and distribute. 5X minus 5Y equals 200. 4X plus 4Y equals 200. Okay, I'm going to make 20s here. I'm going to multiply by 4 on top. I'm going to multiply by -5 on the bottom. Let's come up here. 20x minus 20y equals 800. -20x minus 20y equals -1000. Okay, so this eliminates. -40y equals -200. Divide. So that means y is 5. Okay, and then let's substitute into the top over here. So we're going to get 5x minus 5 times 5. I really need to leave more space in these problems. Equals 200. 5x minus 25 equals 200. 5x equals 225. And x equals 45. Okay. So rate in still water is going to be 45. And we got the rate of the current was 5, and that's in, both are in kilometers per hour. All right. Number 3, we're just going to go over the setup real quick because it's just like the first two. Okay. Not actually going to solve the system. I'm going to leave that to you. If you want to check with me that you did it correctly, just send me an email or whatever. RTD. So we have a jet travels against a jet stream. So I'm going to go against JS. And then we're going to go with the jet stream. All right, let's see what we know. 3,020 miles against the jet stream in 4 hours, and 3,660 miles with the jet stream in the same amount of time. What is the rate of the jet stream in still air? What's the rate, what is the rate of the jet in still air? What is the rate of the jet stream? So we're getting against the jet stream, we're going to slow down. I'm going to say X will be rate still air. Okay, the normal speed of the jet. Y is going to be rate of jet stream. Okay. Against the jet stream will slow us down because we're fighting it. So that's going to be X minus Y. With the jet stream, it's going to speed us up. So that's going to be X plus Y. And your system here is going to be 3,020 equals 4 times X minus Y. And then 3,660 is equal to 4 times X plus Y. Okay. Number 4, a little different. So let's start by making our RTD chart. Okay. So 2 cyclists leave towns 111 miles apart at the same time and travel toward each other. One cyclist travels 7 miles per hour faster than the other one. If they meet in 3 hours, what is the rate of each cyclist? So we have 2 cyclists here. We're going to call one the slower cyclist, and then we've got the faster. Well, that does not look like cyclist at all. Okay. Faster cyclist. All right, so what do we know here? Okay, so they're 111 miles apart. Well, that doesn't tell us anything about how far each one went. What we do know is they meet in 3 hours. So time is 3 hours for each. Okay. And let's take a look at this sentence. One cyclist travels 7 miles per hour faster than the other one. So let's say the slower one's rate is, 10 miles per hour. Then the faster one must be going 17, okay, because it's 7 miles an hour faster. If the slower one's rate is 20 miles per hour, then the faster one's going 27, okay? So I'm going to call the rate of the slower one X, because I don't know what that is. Whatever this is, this one, the faster, has to be 7 faster than it, so I'm going to call it X plus 7, okay? And we don't really know anything about their individual distances, so I'm not going to fill this in, but all I can do, I know distance is rate times time, so this one's distance algebraically must be 3 times X, or 3X. Oops. And this one is going to be 3 times X plus 7. Okay. So what we do know here is that their total distance is 111. So this distance plus this distance must add up to 111. So we're going to go 3x plus 3 times x plus 7 equals 111. So we don't even have a y here. 3x plus 3x plus 21 equals 111. 6x plus 21 equals 111. So that is 6x equals 90, divided by 6, divided by 6. So x is going to be 15. Okay, so we just found that the speed of the slower one is, the speed of the slower one is 15. So slower equals 15, and what is that, kilometers? No, miles. 15 miles per hour. And that means the faster one is going 15 plus 7. So the faster is going to be, 22 miles per hour. Okay? Sometimes using a second variable isn't necessary. All right, last one. So RTD. 2 airplanes leave an airport at the same time and travel in opposite directions. One plane travels 84 kilometers per hour slower than the other. Okay, so kind of the same thing as before. The 2 planes are 16,002 kilometers apart after 9 hours. What is the rate of each plane? So again, slower plane, faster plane. Okay, so what can we fill in here? 9 hours for each of them. Okay. Let's think about what this sentence means. All right. So the slower plane goes 84 slower than the other one, than the faster plane. So if I call the faster plane x, the slower plane 84 slower than that is going to be x minus 84. Okay, and the 1602, again, doesn't tell us about their individual distance, tells us about their total distance. Okay, because they're 16,002 kilometers apart, so the total total amount they have to fly to meet is 16,002 kilometers. So for this one, the distance can be represented algebraically by 9 times x minus 84. And for this one, it's 9x. Okay, so we know these 2 distances have to add up to 16,002 kilometers. So 9 times x minus 84 plus 9x equals 16,002. 9x minus, what does that multiply to? 9 times 84 is 756 plus 9x equals 16,002. 18x minus 756 equals 16,002 plus 756 plus 756. 18x equals 16,758. Divide, and that is 16,758 divided by 18. X is 931. Okay, so that means the faster, okay, so if you look back at our table, we called the faster plane's rate X, so that's going to be 931. And the slower is X minus 4, so slower equals 931 minus 84, which is 847. Okay, and those are both kilometers per hour. All right, we are all set.